All right, so we're going to pick back up where we left off last time. And when we worked last time, we had come across two different things. Let me go back just a bit. One idea that we had come across is this sort of idea that it almost looks like a linear equation, right? The idea that I've got only one x in the problem, it's inside as an angle, and I want to move everything else to the other side, and then I want to think about my unit circle, basically, right? And then on this one, I ran into the same kind of thing. I only have one x in there. That is, there's only an x in one location. But the problem I ran into, or the difference I ran into on this one, is because it said 3 theta, that in the end, or 3x, in the end I'm going to have to divide by 3, which means I need 3 times as many solutions to divide by. So I found my first 2 solutions on my unit circle, and I added 2 pi to each one of them, and then I added 2 pi to each one of them again. And then when I divided everything by 3, it was still within 0 to 2 pi. Okay? Now on this one, what's different? There's 2 things that are different about this. I got a squared. What else? I actually have a half angle on this one as well. So believe it or not a lot of that's going to come into play as we solve the problem, but it will on some of the others. So the first thing we would do is what here? Move the 2 over. I think so. So we're going to add 2 to the right-hand side. So I have sine squared of x over 2 equals to 2. Now, the fact that this is squared, that part does come into play now. How do you get rid of a squared? You square root. And just like you did back in algebra, you're going to square root here too. So this square root's going to eliminate that squared. So this is going to leave me with sine of x over 2 on the left. And it's going to give me a square root 2. And actually, very technically, it's going to give me plus or minus a square root of 2 on the right. On this one, it's not going to matter too much, but if it were different numbers, it would. So what happens here then? Well, do you remember when we graphed sine functions? They sort of had this flowing, waving nature kind of thing going on, right? And that was really good, but what was the highest value and the lowest value that we ever got? 1 and negative 1. What is this value? Is it? So if you're not sure, grab your calculator. Somebody tell me what's an approximation for square root 2? .4 is correct. So thinking about your graph again, the question this is asking is that I have a curve that goes back and forth between 1 and negative 1. And the question it wants to know is when is it going to equal 1.4? And the answer is never. It is never going to get to that point, right? So, I mean, if this had been square root 2 over 2, that'd be okay. And in fact, square root 2 over 2 would be on my unit circle, and we'd be all set for that. But it isn't. So this is no solution, which is the 0 with a slash through it, or you can write the word no solution. And jot yourself down a note so that when you look back at this, you remember why. This is because, and we can write it this way, negative 1, let's do this, is less than or equal to sine of x, or x over 2 if you prefer, is less than or equal to 1, and square root of 2 is approximately 1.4, which is bigger than 1. It can never equal that. And in terms of a picture, what you sort of should be thinking is that you've got this picture going on something like this, and you're asking yourself here up here at 1.4, when am I going to cross this dotted line? And the answer is I'm not. There's not a possible way to do that. Does it make sense? Okay. Let's take a look now at one that actually has a solution. That's a half angle, because I told you the half angle really didn't come into play in that, did it? Actually, not at all. So taking a look at this, I know this has a half angle, but ignore the half angle for the moment. The question is, where does cosine equal 0? So thinking about your unit circle, where in the world on your unit circle does your cosine value equal 0? Nope. Okay, that's right. Okay, so I'm hearing both the radian and the degree measure. So Cole just told me that it's at 270 and 90. Pi halves is the 90. What's the 270? 3 pi halves. So remember, the cosine value on your unit circle is the x-coordinate. So some of you were telling me that it happened at x equal, or at the 0 right there, but this x-coordinate is actually 1, 0, right? So the sine value equals 0 there, but not the cosine. All right, so pi halves, though, is one of those locations, and 3 pi halves is another one. And this isn't like my double angle or quadruple angle, or no, it was 3, wasn't it? It was 3 theta that I had last time. I needed more solutions because I was going to end up dividing by 3. Well, what am I going to end up doing here to find out what theta is? Multiplying by 2. So I don't need additional solutions. As a matter of fact, I'm going to end up with fewer solutions. So what is 2 times pi over 2? Pi. And what is 2 times 3 pi over 2? 3 pi. And my answers are supposed to be between 0 and 2 pi, which means 3 pi doesn't answer the question that's asked, right? It's not a solution in the interval I'm looking at. Does it work in the problem? Yes. But it doesn't fit within the description of the solution I'm looking for. Does that make sense? So I only have one solution between 0 and 2 pi. Just theta equals pi. All right, so what is different about number 5? It is tangent. We haven't done tangent yet. That's true. What else? There's 2 fractions, and not only are there 2 fractions, but they're added together inside my angle, right? Okay, that idea of being inside the angle, that's something different. We haven't had any adding and subtracting within the angle yet on these problems. Okay, so what we need to do first is to deal with the tangent part of it, which is actually what TJ mentioned. So where on your unit circle does tangent equal 1? .45 degrees. In fact, all the 45 degrees, we've got ones and negative ones, right? The 4 different quadrants. What are those in radian measure? Pi fourths. And then we have 3 pi fourths, 5 pi fourths, and 7 pi fourths. But we want to make sure we get the tangent value to be 1 and not negative 1. So which ones do we have? 5 pi fourths. We get that one too. All right, so right tangent is positive in quadrant 1 and quadrant 3, right? So these are the 2 that we would want to have. And we'll be careful as we're working because I could also add pi and subtract pi from these because I'm going to be doing something weird. I'm going to go one more across here. So if I did 1, 3, 5, 7, it would be 9 pi over 4 to put me all the way back into quadrant 1. I don't know if I need that or not. I can't remember. I could look, but just bear with me so you can think about how you think about this, okay? Because the reason I mention this is because this pi thirds right here, I'm about to subtract it, aren't I? And if I subtract pi thirds, it's going to shift everything between 0 and 2 pi. And it's going to shift it and make it a little bit smaller than it was before, which is going to change whether or not I'm actually looking at the right angles. So I might actually need the, oh, and I put 9 pi over pi. Nobody wanted to say anything. You know, I have other classes, and they look for ways to tell me that I did something wrong. You guys just sit there and stare at me. You can tell me, hey, wait a minute, there's a problem there. All right, so I'm not sure if I need the 9 pi fourths, but we'll see real quickly. All right, so solving for theta would be doing what next? Subtracting the pi thirds. Okay, so in order to subtract pi thirds from any of these values, because these are all different values that I need to take the pi thirds from, yes, I would do it to all of them because these are all different possible values. But I run into a problem. What problem do I run into? I need a common denominator. What will my common denominator be? 12. So if I have pi over 4, that's the same thing as 3 pi over 12, right? And I'm subtracting pi thirds from that, so I'm subtracting 4 pi twelfths. And then 5 pi over 4 would be 15 pi over 12. I just multiply the top and bottom by 3. And I'm subtracting 4 pi over 12 from that one. And then 9 pi over 12, so 9 pi over 4, would be 9 times 3, or 27 pi over 12. And again, I'm subtracting 4 pi over 12. Okay, is everybody with me? Okay. What happens on the first one? I have a negative pi over 12. We'll deal with that in a minute, but let's finish the others. How about 15 pi over 12 minus 4 pi over 12? And the last one? So if this weren't theta over 2, let's just say it just said theta, and we were done now. Then the first solution, negative pi over 12, we would have to exclude it, correct? Because it's not between 0 and 2 pi. But we would get to include the 11 pi over 12. That one's good. And we would get to include the 23 pi over 12. That one's good. Because it's just slightly less than 2 pi, right? But I don't have theta equals. I have theta over 2 equals. What's my next step? Multiply by 2. Whoops. All right, so I've got theta on the left. What are my 3 values here in the right-hand side?
Pi 6. Pi 6.
Thank you, Lauren. Now I have to decide, based on these 3, which ones of them fit between 0 and 2 pi. Clearly the first one still doesn't work, right? Not between 0 and 2 pi, because it's negative. Is 11 pi over 6 between 0 and 2 pi?
Yes.
Yes, just barely, right? Yeah. How about 23 pi over 6? No, that is far too large, so it does not get included either. And I have only one solution in the middle. But I don't really know that until I get to the very end, right? So don't eliminate too soon because you won't know. Okay. I want to show you one variation in this section, and this is the idea that not all of these ones are on the unit circle. I know that that's a big surprise because we do so many of them that we think of in that way, and we do that because it's good reasoning skills and we want you to reason from the unit circle, but not everything is in a unit circle. Okay, so I need to talk to you about what happens when it's not. So if you take a look at this one says sine of theta. The directions are the same as far as between 0 and 2 pi. I'm looking for my answer. The difference is that I get to use a calculator on these. So grab your calculator out. If you don't have it out already, you're going to need it. And I've got sine theta equals negative 0.2. So the first question I want to pause and ask you is, where is sine negative? 3 and 4. Agreed? So I'm going to get 2 solutions to this problem. But my calculator is not going to give me 2 solutions to this problem. It's only going to give me one, and I'm going to have to figure out how to find the other one based on what I know about how the unit circle works. Even though I don't have a value on the unit circle, I have to use that knowledge in this problem. So do you remember when we did back in, I don't remember what section it was, inverse trig functions, where we did inverse sines and things like that, the sign with the little negative 1 up there? That's what we're doing right here. So we're going to take the inverse sine of the sine of theta and the inverse sine of negative 0.2. And of course, on the left-hand side, the whole point is that that leaves me with theta. But on the right-hand side, I need a calculator, and that's what I need the calculator to do. So take your calculator, do second sine, which gets you sine inverse, and then tell it negative 0.2. And somebody's going to let me know what that is. Okay. And it says two decimals, so let's go with negative 0.20. And it is totally chance and coincidence that it's the same as the sine values that I had before, right? The fact that these two match is very strange. Not at all normal and not at all going to ever be repeated probably in any other problem you do. Okay, so please don't think that I didn't do anything and I got the same answer. It just happened this time, okay? All right. Okay, make sure that you're in radian mode. Because you should. Oh, do you see there at the bottom, times 10 to the 1? Yeah. Your calculator, or negative 1, your calculator's putting it in scientific notation. don't know why. We can try and figure it out after class, though, TJ. But I'm glad I figured it out right now because that looked very odd, too. All right, okay, here's the deal, though. That answer is not on the 0 to 2 pi interval. Agreed? No. And in fact, we knew, or we should have known from what we've done before, that it wouldn't be. But negative 0.2 would be down here in quadrant 4. Good. All right, so it is down here. This right here, this angle is negative 0.2 radians. Okay? How can I find out what that would be if it were positive in radians? What would I do to get the positive radian value instead? That would change my angle, which wouldn't help, yeah. Why is this negative from the picture I just drew? Because it went clockwise, actually, right? So clockwise, when I move clockwise, I end up getting negative angles, correct? So what if I go counterclockwise? That gives me my positive angle, yeah? So how do I get from here back to here going positive? I add 2 pi. Very good. I heard a couple of you saying it. Yes, I add 2 pi. So this theta value, negative 0.2, plus 2 pi will give me the answer in quadrant 4. I still have a quadrant 3 answer that I haven't gotten to yet, right? But adding 2 pi to a negative angle will swing, and what it'll do physically is it'll swing me back all the way around to here. Same spot. It'll just be moving in the positive direction now instead of the negative direction. All right, so what is negative 0.2 plus 2 pi? Okay, so this is definitely one of my solutions, 6.08. I need to put it down here. I'm going to run out of space. So this is one of my solutions, but it is not the only one because I should be getting an angle over here as well, somewhere over here. Sine is a measurement of the y distance, isn't it? So y measures the distance from my x-axis down to here. So I need something mirror image. So imagine flipping this over the y-axis, okay? That's why this piece is at the same angle as this piece. This distance has to measure the same distance. So if I put a position on here, then, whoops. This distance has to measure the same thing as this distance because that's what sine is. Sine is y on my unit circle. I know I don't have a whole unit circle drawn in here, but can you imagine it being there? Yeah? Okay. So what I need is I actually need the same angle. And if this angle is 0.2, well then so is this one, right? It's the same distance in an angle measure as well. So I have 0.2 here as well. But that's not how we measure angles. We measure angles from the positive x-axis all the way around to wherever we're stopping. Which means what I need is I need that measure. How do I get that measure in red? Nope. Okay, but that's degrees. Pi, right? So if I took this red value, that I've kind of marked here, and go from here and I stop short, right there, I've gone pi, correct? And if I add 0.2 more to it, then I'm where I need to be. So this value right here is pi. Let's do it in red just to keep it differentiated. It's actually pi plus 0.2. Okay. Remember, it's not a negative 0.2. The negative indicated a direction, correct? And my direction is now going the positive direction, so that's why it's positive 0.2. So what is pi plus 0.2? What is it? 2.94? So I have two solutions. One is 6.08, and the other is 2.94. So you thought that when it said you could use your calculator, it would be easier, didn't you? But it requires a fair bit of reasoning, and it doesn't feel quite as comfortable because neither of those numbers sort of resonate with you anymore. You don't think in terms of the values without pi associated with them very well, right? Yes?
Pi subtracted by 0.2 is 2.94. Are we adding?
Oh, did somebody give me a wrong value? TJ, did you do that? Oh, we'll fix it. Okay, what was it, Landon?
Pi plus 0.2 is 3.34.
3.34. Thank you. We'll fix it. And I should have looked because I have it written down too. Okay, are we good? Okay, we have one more in this lesson. Same directions. That is to say, we're going to use a calculator. We've got to be between 0 and 2 pi. This is cotangent, though, and I don't have a cotangent button on my calculator. Do you? But I do have a button for tangent. So I can change this, into tangent, right? So if cotangent of theta is 2, what is tangent of theta? 1/2, right? It's the reciprocal. And then I can work with that just fine. Again, the tangent 1/2 is not on my unit circle. Sine 1/2, yes. Cosine 1/2, yes. Tangent theta, no. Right? Tangent 1/2 is not there. So I can do this. I can do the inverse tangent of tangent of theta and the inverse tangent of 1/2. Now, let's pause for a moment. You can get me that answer, but pause for a moment and think, which quadrants should I be getting answers in? 1 and 3. Because tangent is positive, right? Cotangent is positive. In fact, 2. Tangent and cotangent positive. Okay. It gave you a value, right? What did inverse tangent 0.5 or 1/2 look like? 0.46? Good. I checked my solutions, and I agree. All right, so 0.46, and that 0.46 is in quadrant 1, right? And you can think about what I'm about to say from 2 different perspectives, or what we're about to do, and so I'll tell you both of them. One perspective is very much like I just did sine just a minute ago, right? This angle measure that went up from this axis has to come over here down from this axis the same amount. Okay, so I've got to have a 0.46 over here for the same reason. And so I find it in the same way that I found that very last piece of the last one. And how did I find it? I added pi. So I also have then 0.46 plus pi, and I have 3.61 written down. Do I have anybody agree with me on that? Yes? Okay. So I have 2 solutions. So this is one way to think about it. The other way to think about it is to remember for yourself that tangent, when we drew graphs of them, has a period of pi. Do you remember doing that? When we drew tangent graphs? So every time we have a tangent graph and we're looking at a tangent value, we have the same value again, pi units later. So we didn't do that with sine and cosine because they had 2 pi, and that's outside of my 0 to 2 pi interval. But I can think about it from that way with tangent because it's got that pi interval instead. So I have 2 solutions on this one.